Section 5.7, factoring difference of two squares and sum difference of two cubes. So objective 1, difference of two squares. A binomial is the difference of two squares if both terms are squares. So when both terms are perfect squares, you can use this. The sign in between the terms is a minus. That means it's difference. So examples, you have x squared minus 9, 16c to the fourth minus x to the fourth. Every single term is a perfect square. And how we do that, it's going to be the square root of a and the square root of b, and you're going to put a plus and a minus version of it. So example 1, we want to factor each of these. So number 1, we have 4x squared minus y squared. Let's take the square root of each term. So the square root of 4 is 2, the square root of x squared is x, and the square root of y squared is y. So they're all perfect squares. That's good. And it has a difference. So we're good there. Now we want to combine them together with a plus and a minus. So we have 2x plus y and 2x minus y. Let's do the same thing for b, or excuse me, number 2. We have 1/4 x squared minus 16. So there's a difference. We're good to go. Now we need to see, are these perfect squares? So when we think of perfect square of 1/4, that's 1/2, because 1/2 times 1/2 equals 1/4. So that works. The square root of x squared is x. There's a minus, so we're good. And then the square root of 16 is 4. Now we're going to combine these with a plus and a minus. So we have 1/2 x plus 4 and 1/2 x minus 4. Now, here are just some special things that are going to come up in 5.6 that I just want you to write down now. You see how we have x squared plus bx plus c? You've noticed we're factoring. So if it's plus plus, it's going to be plus plus. If it's minus plus, it's going to be minus minus. So when the c is positive, you have the same signs, and you use the sign in front of b. Now, if c is negative, you're going to have minus plus, and the greater factor of c gets the sign in front of b. That'll make more sense when we go over it in 5.6, but I just wanted to express this early and get it out there. So objective 2, factor the sum or difference of two cubes. So when we have perfect cubes, so just like perfect squares, except perfect cubes are number times number times number. It's 3 times. If you have a sum, it's a plus b times a squared minus ab plus b squared. And if you have a minus, it's a minus b, a squared plus ab plus b squared. So what you want to do is you want to take the perfect cube out of each term and then plug it in for a and b. So for a, that doesn't work. For a, we have x cubed plus 1. So the perfect cube root of x cubed is x, because x times x times x is x cubed. And the perfect cube of 1 is 1, because 1 times 1 times 1 is 1. So now we have our a and we have our b. We're going to plug it into the formula a cubed, excuse me, wrong one, a plus b times a squared minus ab plus b squared. So we're going to plug in a and b. A is x, b is 1. A is x, we're going to square it. A is x, b is 1. And then b squared. Now we simplify. So x plus 1 times x squared minus x. It's minus x because x times 1 is just x. And then plus 1 because 1 squared is 1. And that's how we factor. You do not need to take it any step further because x squared minus x plus 1 is prime. That means there are no two factors other than itself and 1 to multiply to it. Alright, part B. We have y cubed minus 64. So we need to make sure that each of these are perfect cubes. It doesn't matter if it's minus or plus. So the perfect cube for y cubed is y, and then the cube root of 64 is 4. So we have our a and we have our b. Now we're going to use the minus one because we're minusing in between. So we have a minus b times a squared plus ab plus b squared. So we're going to plug in a and b. A is y, b is 4, a is y, times ab, or plus ab. So that's y times 4 plus b squared, so 4 squared. Now we simplify. So we have y minus 4, y squared, plus y times 4 is 4y, plus 4 squared is 16. And there we go. Alright, part C. We have x cubed times y to the 6 minus 27 z cubed. Now, doesn't matter, as long as we have perfect cubes for each term, we are good to go. So the perfect cube to x cubed is x. The perfect cube to y to the 6 is y squared, because y squared, and y squared is y to the 6. Remember, we add our exponents if we're multiplying. And then the perfect cube of 27 is 3, and the perfect cube to z cubed is z. Now we have our a, and we have our b. And we're going to use the minus formula because we're subtracting in between. So we have a, which is xy squared, minus b, which is 3z. Now we have a squared, so xy squared squared, plus ab. So a times b is x cubed. I'm running out of space. Let me start this over. So we have a minus b, so xy squared minus 3z. A squared, so that's xy squared squared, plus a times b, so a is x cubed, or excuse me, x squared, so xy squared, times b, which is 3z. And then that's plus b squared, so plus 3z squared. Now we need to simplify. So xy squared minus 3z. Remember when we are squaring our exponents, we multiply them, because when we multiply exponents, we multiply them, and then when they're on exponents, we put them together as multiplication. So we have x squared is x squared, y squared squared is y to the 4th, that's fun to say, plus so we have xy squared times 3z is 3xy squared z. It doesn't matter what order you put them in, but usually you want to put the number first and then alphabetical. And then we need to square 3z. So 3 squared is 9 and z squared is z squared. That was a mouthful. Okay, if you need it, I have extra problems, but if you don't, go ahead and move on from here. Alright, so number 1, we have 9x squared minus 1. So this is a difference of two squares because they're perfect squares and we have a minus. So the perfect square to 9 is 3, x squared is x, and 1 is 1. So we have 3x plus 1 and 3x minus 1. Number 2, we have 98n squared minus 200. So, is 200 a perfect square? It is not, nor is 98. But, do they have something in common? Yes, they have 2. So we're going to take the 2 out. We have 49n squared minus 100. Now we have perfect squares because the square root of 49 is 7, the square root of n squared is n, and then the square root of 10 or 100 is 10. So we combine them together to get 7n plus 10 and 7n minus 10. Alright, number 3. We have 81v cubed minus 900v. So v itself does not have a perfect square, nor does 900, but they do have something in common. They have 9v in common. So we have 9v squared minus 100. Now we have perfect squares. The square root of 9 is 3. The square root of v squared is v. And then the square root of 100 is 10. So we have 3v plus 10 and 3v minus 10. Alright, number 4. We have x cubed plus 125. So now we have cube roots. We have cube roots because we're dealing with x cubed, and 125 does have a perfect cube root. So this cube root of x cubed is x, and the cube root of 125 is 5. And we're adding, so we use our formula of a plus b times a squared minus ab plus b squared. So our a is x, our b is 5. We have x plus 5, x squared, minus a times b, so x times 5, plus b squared, which is 5. Simplify, so we have x plus 5 times x squared minus 5x plus 25. Alright, last extra example, number 5. Number 5 is negative 27u cubed plus 125. Does negative 27 have a cube root? It does. Negative 3 times negative 3 times negative 3 is negative 27. So the cube root of negative 27 is negative 3, and the cube root of u cubed is u, and we know the cube root of 125 is 5. Now we combine them together, we have a plus, so we're going to use the a plus b formula. So we have negative 3u plus 5, negative 3u squared, minus negative 3u times 5, plus b squared, which is 5 squared. Now we need to simplify. So negative 3u plus 5, we need to square negative 3u, so that becomes negative 3 squared is 9, u squared is u squared. We have minus minus, so those become plus. So we have 3u times 5 is 15u. And then 5 squared is 25. Be careful on your signs.